Hi, and welcome to lesson 2 on least common multiples. So lesson 1 was greatest common factors. The other kind of big idea in terms of working with numbers is least common multiple. So a multiple is the result when you multiply one number by an integer. So for example, the multiples of 3 are 3, 6, 9, 12. If we just multiply by 2, by 3, by 4, by 5. The least common multiple of two or more numbers is the smallest number that is divisible by everything. So for example, the least common multiple of 2 and 7 is 14. So it's kind of a little bit odd because it's got the word least in it, which makes you think that it's going to be small. But the least common multiple has to be a number larger than any of the individual numbers. So the number 14 is larger than both 2 and 7, okay? So there's two ways that you can find the least common multiple. Option 1 is really just to do skip counting, okay? So you take a calculator and you skip count by 18s, okay? So if I skip count by 18s, I go 18, 36, and honestly, I would need to now grab a calculator. 18 times 3 is 54. 18 times 4 is 72, times 5 is 90, 108, 126. We'll stop there and see. And then I'm going to do the same thing. I'm going to skip count by 20s and by 30s. So this will be 20, 40, 60, 80, 100, 120, 140, 160. So you can see that I'm going to need to keep going on my 18s. I didn't really know where to stop, so I just stopped at 126. But I'm past 126 with my 20s and I haven't got to a common number yet. So I'm just going to do this one a little bit longer and then we'll come back. So we'll stop at 200 and we'll go back to our 18s and we'll see. So after 126, so let's see, this was times 1, 2, 3, 4, 5, 6, 7. So 18 times 8 is 144, and 18 times 5 is 162, or sorry, times 9, and then 18 times 10 is 180. Okay, here's a common one. And so now let's go by 30s and hope that we get those 30, 60, 90, 120, 150, 180. Oopsie, 180. Okay, so you can see that I end up with, that is the smallest number that all three will go into. So the least common multiple is actually usually a really big number, which is kind of confusing, but the least common multiple is 180. Now, so that is always an option. You can always skip count, but not the most quick, right? It's not the fastest way to get there, especially if it's, sometimes you'll have numbers like in the thousands, and do we really want to skip count all that way? So there is a way that we can do it using our prime factorization. So on the side of your paper there, the steps are you write the prime factorization of each number. So we're going to start by doing that. So remember, 18 is 2 times 9. This is 3 times 3. So the prime factorization of this is 2 times 3 squared. So 20 is 2 times 10. 10 is 2 times 5. 2 times 5. So this is 2 squared times 5. 30 is 3 times 10. That becomes 2 times 5. So this is 2 times 3 times 5. Now, as I stated, the least common multiple is actually a number that's larger than any of the individual numbers. So it's going to be something bigger than 18, 20, and 30. And quite honestly, it's probably going to be quite a bit bigger. So to figure out what that is, you have to look at all of the different factors. So when I look at the prime numbers that exist here, I've got 2's, 3's, and 5's. Okay, so my least common multiple is going to have 2's, 3's, and 5's I'm going to use. And what you want to do is you actually want to take the largest exponent. So there's 1, 2 here, 2 2's here, 1 here. So I'm going to take 2 to the power of 2 because I want to take the largest. For my 3's, my largest is 3 squared. And for my 5's, I have a single 5. So I'm going to go 2 squared times 3 squared times 5. And when I do that, I get 180. Okay, so we get the same answer whether we skip count or do the lowest common multiple. But I think if you can kind of get onto the process, it's a little bit quicker. Okay, so let's look at 12, 18, 25, and 30. So we start off by writing the prime factorization. So 12 is 4 times 3, which is 2 times 2 times 3. So this is 2 squared times 3. 18, 2 times 9, that becomes 3 times 3. So that's 2 times 3 squared. 25 is 5 times 5, so that's just simply 5 squared. 30 is 5 times 6, 5 times 2 times 3, so that's 2 times 3 times 5. So if I look at all of my different prime numbers, I have 2, 3s, and 5s, and I want to take the highest exponent. So I've got a 2 squared. For my 3s, my highest is a 3 squared, and for my 5s, my highest is a 5 squared. So my LCM, my lowest common multiple, is 2 squared times 3 squared times 5 squared, which is 900. That should be a times sign. Okay, so you can see that if I had to skip count that, I'd be going for a while, right? And it's 4 numbers to skip count, so who wants to do that? So it's quite a bit quicker. Let's do one more example together. 15, 32, and 44. So 15 is 3 times 5. 32 is 4 times 8. That's 2 times 2. And I've done 8 enough times to realize it's 2 times 2 times 2. So this is 2 to the power of 5. 44 is 4 times 11, which is 2 times 2 times 11, which is 2 squared times 11. This one's 3 times 5. So I've got 2s, 3s, 5s, and 11s. So my lowest common multiple, so the highest of my 2s is 2 to the power of 5. The highest of my 3s is just a plain old 3, and a plain old 5, and an 11. So when I multiply all those together, I get 5,280. So again, I think we can all agree that skip counting that high would not be that fun. All right, let's look at the next example. So we can do word problems, and these word problems are ones that kind of involve skip counting. So this says Jim has a rectangular tile that measures 16 by 40. What is the side length of the smallest square that he could tile with those rectangles? So basically, if you were to kind of draw a little picture of this, this would be like, okay, I've got a rectangle that's 16 by 40, and he wants it to fit into a square. So this would be a 16, and if I was going this way, I'd have another 40. So basically, I'm trying to find, like if I'm skip counting by 16s and by 40s, when do I get to the same dimension? So it's a skip counting question. So that means it's a least common multiple. So I want the lowest common multiple of 16 and 40. So 16 is 4 times 4, which is 2 times 2 and 2 times 2. So that's 2 to the power of 4. 40 is 4 times 10. It's 2 times 2 and 2 times 5. So that's 2 to the 3 times 5. So my lowest common multiple will be my highest of all of my difference. So 2 to the power of 4 times 5, which is 16 times 5, which is 80. Okay, so that means that I would need a square with a side length of 80 centimeters. So if I had one that was 80 by 80, I could fit in all my little rectangles inside of there. Okay, a bar of soap has a shape the size of a rectangular prism that is 10 by 6 by 3. What is the size of the smallest cube that can be filled up? So this is essentially the exact same thing. I have a bar of soap that is a rectangular prism, so it looks like that, which is 10 by 6 by 3, and I want to stack them in a box in order to create it. So it's the same idea. I want the lowest common multiple of 10, 6, and 3. So 2 and 5, 2 and 3, and that's just a 3. So I've got 2s, 5s, and 3s. My lowest common multiple is going to be, because I only have powers of 1 anywhere. So 2 times 3 times 5 is 30 centimeters. So my cube has a side length of 30 centimeters, right? So it's a 30 by 30 by 30 cube. Okay, so you can go ahead and practice a few questions like this if you would like. And then when you're done, there's a mastery check.